Today's lecture, we're going to learn about the formation and distribution of volcanoes, mountain ranges, and earthquake. And what would be the relationship to the formation and distribution of these to plate boundaries? And what is also the relationship of plate boundaries to plate tectonics? Right? Sana all relationship. Okay, so these three terms are interconnected. They're interrelated with each other. Taas ng introduction ko sa the lesson. So basically, today we're going to learn about plate tectonic theory, plate boundaries, volcanoes, mountain ranges, and earthquakes. That's it. Okay, so for us to learn or for us to understand the concept behind plate tectonic theory, we're going to learn first about the lithosphere. Okay, so when we cut a cross section of the Earth glass, this is what it looks like now. We get a part of it. So we have here the core and the mantle and the crusts, and this is part here. The crust is the livable part of the Earth, and so this is made of what we call the lithosphere, the crust, and the uppermost mantle. For definition, it's the rocky outer layer of the Earth. You might wonder, what? Rocky? It's an ocean. Remember, below the oceans are basaltic rock, which makes up our oceanic beds. So it's still a rock. So all of it comprises the lithosphere, one of the great system, or one of the important system in our Earth. Okay, so again, in the definition, it consists of the two Earth's main layer, the crusts. So when we zoom this is what we get, this illustration. We get it from Wikipedia. So we have two types of crust, the oceanic crust and the continental crust. The oceanic crust, basically, from the word itself, you can find it in the ocean, the bodies of water, particularly in the ocean. Sorry. Okay, this is denser compared in contrast to continental crusts. Okay, this is made up of basaltic rock, and the continental crust is made up of granitic or granite rock. So this is where we live, in the continental part, and this oceanic crust makes up most of the Earth. Okay, so basically this is the crust. The oceanic crust and the continental crust are also one of the most repetitive terms throughout our lecture, so you must remember that one. And after that, in the crust, you have the uppermost mantle. Not the whole mantle itself, but only the uppermost, extended around 100 kilometers from here up to here. Some books would say 80 to 120 miles in kilometer. How much is that? Do the math. That's around, I guess, that's 200 kilometers. No? Depending upon the books, because you might wonder why is the figure is not exact, because when you are going to measure, when geologists try to measure, depends upon the area. There are areas who are, like for example, in the ocean, it's deep enough so that the measurement from the crust up to the mantle is lower compared to the figure. If you're going to measure the continental and to the part of the mantle which is also belongs to lithosphere. And so after the 100 kilometer here in the uppermost part, it's no longer part of the lithosphere. It is because of its properties. Here in this portion, the mantle is ductile. So, but when it goes beyond in the lower part, when you go up here in the stratosphere, it becomes viscous. So it can be no longer part of the lithosphere. So this makes up the crust and the uppermost mantle of what we call the Earth, the Earth's lithosphere. Okay. Now, what will happen if we're going to connect all of the lithosphere, the oceanic lithosphere, and the continental lithosphere, or the lithosphere in general? This is what we get. The planet Earth. The Earth's lithosphere, and we're going to combine all together makes up the Earth. But look at this one. What are these lines for? What are these black lines for? Okay, these are boundaries. Okay, these are boundaries, and these are chunks of lithosphere. So when we are going to fit all of this, it becomes the whole Earth's lithosphere. But when we get the chunks of this lithosphere, that's what we call plates. Right? Tectonic plates, or lithospheric plates, or plates in general, it's our pieces of Earth's lithosphere. Okay, you might ask, how do they make this line? How do they make this boundary? So geologists would try to get data on the geological event that happened here. So most of the event that occurred happened on this area. So they try to trace it, and this is where we get the boundary. Okay, so it just like when you get a plate, a breakable plate, and then you are going to let it fall on the ground. What will happen? Okay, it will break, and there are chunks that are bigger and there are smaller. Same goes with our tectonic plates. There are bigger, there are larger plates, and there are smaller plates. Okay, and by the way, these plates are in constant motion. So even up to this hour, while you're listening to this lecture, it is moving. But however, it's very slow motion, so you cannot feel it. But there are times when they are going to move faster, or they're going to move, so that would cause a lot of geological event, the sudden release of movement. So these are what we call plates. I hope it's clear with you. We have larger plates and we have smaller plates over here, and this is what lithosphere. These are pieces of Earth's lithosphere. Alright, so let's try to look into the category of the plates. We have major and minor plates. So for major plates over here, we have the Pacific plate. Right, so when we connect this one, it goes extend up here, here, and then here. So this is the largest plate of the entire plates, and this is also has the strongest motion. So basically, these areas here, or these countries, the side of these countries, will experience a lot of geological processes and hazards because of this Pacific plate. Next, we have here the North American plate. You can find it here at the lower portion. Okay, it's basically named after the South America. In North America, I'm sorry, I skipped the North America. North American plate, this one. And it extends up to the Arctic, or in the North Pole. It's still big, still large. And then we have here the African plate. The African plate, it looks like it looks like the whole jurisdiction of the Africa. And over here we have the Eurasian plate, the Asia and the Europe combined together to form this Eurasian plate. And next we have the Indo-Australian plate. This one, Australian plate, extend over here. Okay, and we have here the Antarctic plate over the south. We have the Antarctic plate. It was believed that this Antarctic plate and then the Australian plate, makes up the island of Gondwana. Gondwana during the early formation of these continents. Okay, so those are the larger plates. You have noticed that it was named after with the continents that they are in. But actually, these plates are not by continent. You know what I mean? It's not by continent, but it's just named the continent which they are in. Because there are plates that are not by continent. Like for example here, the Europe and the Asia. It's not the Europe plate and Asian plate. It's Eurasian plate. So it is not based. Remember, it's not based on the continent, but just named on the continent where they are located. Okay. So minor plates over here. There's also minor plates or smaller plates. For example, we have here the Nazca plates, the Caribbean plates, Arabian plates over here, Indian plate, and the Philippine plate. And also we have here Cocos plate somewhere up here, and Sunda plate, and etc. There are a lot of minor plates in the world. And those are what we call tectonic plates, the major and the minor plates. Okay. As I have mentioned, these plates are in motion. Right? So you might ask, what are the driving force why they are moving? Right? So it's a very long journey or work by the scientists. Even Alfred Wegener is the proponent of the theory. Did not explain that's the downfall of this theory. But eventually, we have the reason. It's because of the thermal convection, or the heat inside the planet Earth that tries to escape. Okay, remember when it has a high temperature, it always rising up, and the lower temperature always rising down. What this means by thermal convection, they are formed by hot magma rising near the core, rising toward the surface, while the cooler one settled. Okay, so rising, the hot magma rising, and then settle, going down. So it's the cycle continue, and as it moves like this, the portion of here in the lithosphere are moving. Okay, so in short, thermal convection just have to do with how the heat, the magma inside, try to escape. But then again, the cooler magma would try to drag it back down, and as soon as that cycle, so there will be a movement of the plate. Alright, so okay, we get now the concept of the lithosphere that makes up the plates, and the plates which has a movement because of thermal convection. And that leads us to the whole concept of plate tectonic theory. So plate tectonic theory is a theory describing the motion of the plates. So in short, when you talk about plate tectonic or plate tectonic theory, that's the movement of the plate or the motion of the plate. But this theory doesn't have just to focus on the movement of the plate, but it is a very large scale. It's a very a lot of interconnected ideas to it. But it's a very important theory because it enables us to understand the geological process that happen on the planet Earth, as well as the hazards that they may bring. So we will be aware and be educated enough to it. Alright. But first, I'm going to describe to you the motion of the plates along with each other. Okay. So we have here illustration about describing its motion, and as you have noticed, where is that? So you have noticed the motion of these plates are not the same or the same with any other plates. And here, we just here, so you have observed, they are not in the same direction. What I mean is that they're not moving, all of them moving eastward or moving westward. It's totally different. Now, because their motion are different from each other, and as you can see here, this boundary here, when this plate ram towards the other plate. But it's a total different with the motion at the side. Because at this side, there would be a sliding past each other. They're not colliding, they're not ramming. And over here below, they are moving toward each other. I mean, away from each other. They're moving away from each other. So their motion, the cause of this different motion, which leads us to geological processes and hazards that happen on the Earth. Okay. Along here are describing the motion based on how fast and how strong when there is a sudden movement of these plates. And you have noticed that there are longer lines, longer arrows, and there are smaller arrows. This signifies the relative motion of the plate in relation to how strong it is or how fast it is. And as you can see in this illustration, the longer arrows are, you can find the longer arrows here on the Pacific and some portion here in Australia. Meaning to say, when the Pacific plate moves, it is catastrophic, or at least there are a cause of damage. Because one factor that it is fast, the movement is fast, and this is an oceanic plate. So basically it submerges, it subducts. So again, this portion, the sides of the countries residing here and here over in Asia, and here in South America and North America, have tremendous effect of its geological process. And most of the portion here in the planet Earth have a slower motion of plates. Okay, when it have a sudden motion, it doesn't have to be catastrophic. Okay, so that's the motion of the plates. And it leads us to digging down deeper. Okay, the plate boundaries. Alright, so what I mean is that we're going to define or discuss each of those boundaries, each of those motions along the boundary of the plates. As per defined plate boundaries, the edge of the plate where it is in contact with the other adjacent plate. We have three types of plate boundary. One is what we call the convergent plate boundary. What does it mean by convergent plate boundary? It occurs when two plates move toward each other. Here is an illustration of the two plates. One plate moves toward another plate, and so their arrows are moving toward each other. And by that, some of the plates would try to subduct, especially when it's collision of continental and oceanic, because oceanic is denser. So when a plate that is denser would try to subduct over the other one which is not. So this illustration is a good illustration of oceanic and continental crest. Okay, so way back on the map that I've shown you, you have observed that there is a converging boundary in the upper part of the Pacific and the continent to it. Next, we have the divergent plate boundary. It occurs when two plates move away from each other. So in contrary to convergent plate boundary, divergent plate boundary, you're moving away from each other. And so this arrow would symbolize the movement of plate. And so as you can see here, there are rising of magma and there are separation. And as long as it's separated, create a new floor over here. It usually happens in oceanic crust and new sea floor will create mid ridges, and basin will happen over movement of divergence. And next we have the transform fault plate boundary. It occurs when two plates move slide past each other. So there would be no collision or moving away, but it slide past each other. So you can see this one moves backward and this one moves forward, or vice versa. Most of the geological processes happen here are earthquakes. Okay, so those are the types of boundaries. Okay, so now, alright, so with those types of motion of the plates, or what we have known as plate boundaries, these are the geological processes that was made because of that. One is the formation of volcanoes. How are volcanoes formed? One simple answer, it's because of the movement of the plates. So volcanoes are formed to plates primarily because of the convergence. Converger usually formed in convergent plate boundary. So I'm going to show you an animation on how volcanoes are formed because of the convergence, or the convergent plate boundary. Okay, alright, so as you can see here, this is an oceanic plate, submerged or subduct to continental plate. This is the trenches, and there would be a melting of material down here, and eventually it will come up rising above, and in time it will form a series of volcanic chain here in the continent. So these are the volcanoes that you can see in the land, in the continent. Okay, some of the chains are become volcanic mountains, but most of this are erupting. Right? So how about if it's in two oceanic plates? So either way, the denser will subduct. And the same goes with the converging oceanic and continental. There will be melting of materials rising above, and then it will have a chain of oceanic volcanic islands arc. So that's the case of how the Philippines was formed. Okay. Alright, so that's it. So again, the volcanoes are formed because of convergent plate boundary. Okay, so that's how volcanoes are formed. Now we are going to talk about how mountain ranges are formed. The same goes with the volcanoes. It's the convergent plate boundary. It's the convergence of two plates. However, the difference is that in the case of the mountains, the plates that are converging are continental plate. And so what will happen is that there will be a concentration of land masses here on the center. It's the same goes when you fold the paper, right? What can you say? What would you see if you fold paper? If the top portion would create a look like a mountain. The concentration is on the top. So that's how mountain ranges was formed, because two continental plates converge with each other. Alright, and then we will have the occurrence of the earthquake. So the earthquake occurs when two plates converge, diverge, or slide past each other, followed by a sudden release of energy. Now, whatever the interaction, earthquake occurred. So for example, here in the divergent boundary, when two plates move away from each other, there would be a release of energy. There would be an earthquake. Here, as you can see, there are collisions of continents. So there would also be an earthquake. Down here, this is subduction part. Okay, this is a continental oceanic. There are also an earthquake happened. And lastly, in transform fault, sliding past each other, there is an earthquake. So convergent plate boundary, divergent plate boundary, transform fault boundary, there is always an earthquake. Unlike volcanoes and mountains that are formed because of convergence, not divergence, convergent plate boundary, whereas earthquake is Hakot Award. So this is very hazardous. I'm going to show you how the earthquake occurred in a subduction zone boundary. Alright, so here, look at this point. There would be a subduction process happen, and there would be the accumulation of energy, and there would be a plate lock portion here locked, and there would be a stress in between plates. It have to subsidence. There would be an inland subsidence, and there's a motion. Alright, and then there would be a rupture of energy. Okay, so that would be felt the shaking of the ground. Again, I want you to look carefully what had happened. Okay, in the subduction zone boundary, or in subducting plates, there would be a plate lock from the subduction area, and that would lead into the movement of the plates here, seaward uplift and inland subsidence. And as the stress accumulate, there will be a rupture, and so there are shaking of the ground. Okay, so you might ask when and where the next earthquake will happen. The safest answer is OJK. Only God knows. There is no enough measures and instrument that can detect possible early signs of an earthquake, and geologists are still working on it. But there are ways that they have alternative ways. The possibility, only the possibility. So the earthquake and volcanic eruption usually happen along here. Alright, so this is illustration from the Earth's core. This is newest data from the geologists and scientists telling us that there's a lot of earthquake and volcanic eruption that had happened along the plate boundary of the Pacific. Right? So one main consideration why there's a lot of geological process happen here, one is that the plate of the Pacific, again, as I have mentioned in the previous slides, it's strong and fast. Second, the plate is dense because it's an oceanic plate, and it's the largest plate. So the hazard is always on the rise towards this area, including us, the Philippines. So there would be a series of earthquake and volcanic eruption happening here. And so this is what we call, scientists call it, the Pacific Ring of Fire. Because again, there are a lot of volcanic eruption, like a blazing fire. And it looks like a ring. It's like a circle over here. Right? This is a cartoon illustration, the Pacific Ring of Fire. So this would tell us that these areas, including us, are very prone to hazards. Okay? Right? Not just that, not just in this area. There are also portions here experience earthquake and volcanic eruption. Okay. Now let's focus on the tectonic setting in the Philippines. I have here an illustration of the Philippines. So the Philippines was once made by the colliding plates of the Philippine Sea Plate and the Eurasian Plate, portion of the Eurasian Plate here. And so in the history, by subduction, there's a rise of this volcanic arc, which is known today as the Philippines, the archipelago of the Philippines. And the plate, and the plate of the Philippines, the Philippine island, is known as the Philippine Mobile Belt. Okay. Alright, so that's how it happened. And remember, that this is in between two of the largest plate, the Pacific plate, the Pacific Sea plate, that was near to the Pacific plate, which is the largest, and the Eurasian plate. So what would happen if you are squeezed between both giant? They would undergo a lot of stresses. Right? So, and the stresses creates a fault system in the Philippines, from the Luzon extending towards the Mindanao. And so this fault system eventually triggers earthquake when this plate, Sea Philippine plate, and the Philippine Mobile Belt will try to subduct. So the triggering factor would eventually lead to the shaking of the ground with the fault. These are areas that are prone to hazards also. So this is where most of the earthquake happen, aside from the subduction zone here from the fault, and also this is where the locations of most of the volcanoes in the Philippines. Okay, so hazards are always on the rise here in the Philippines. You have noticed here the Palawan is not on the part of the Philippine Mobile Plate. It's part of the Sunda Plate. It's part, which is also part of the Eurasian Plate. So this one, the Palawan Island, is one of the oldest islands in the Philippines. And it's not near in the subduction zone, it's in the center. So there are only few records of earthquake and volcanic eruption, the Palawan, compared to the Philippine Mobile Belt. Lucky you are, Palawan. Sana all. So, that's it. And so this earthquake brings a lot of hazard. The earthquake itself is a hazard that leads to a disaster, which means there's a lot of loss of lives and properties. But this also, earthquake could also be a factor to trigger landslide. Here is an example of a landslide, thanks to their sources. So here is a landslide, and when there's an earthquake, that could trigger mass wasting. In the Philippine setting, there are places, there are houses near the landslide-prone area, which given warning, but not totally complying, because those are the realities of the ground. Sometimes you say, bahala na. Bahala na si Lord, bahala na si Batman. Sanay na kami dito. Like that, loss mentality. You cannot really blame them for cultural and economic reasons. But let's know the risks. Okay. So another triggering, another disaster is from the earthquake is volcanic eruption, and then tsunamis. As in the illustration a while ago, there will be a stress with two plates. There would be movement of the land, and that caused the backward of the water. And then when there's a sudden release, it's sudden forward of the water, which leads into extend to lot of kilometers to kilometer. It causes lives. And so, being said that we are under the natural processes, so we must know, we must be knowledgeable with the hazards, and we must be prepared, and we must communicate, we must listen to the news, the government agencies, and what to do and how to do it. Alright, so that's it. Okay, so I hope that you have learned something, that you can take away something from a lecture. Now, those of you who are expert in this field, I'm sorry if I have something said wrong, but I am at least 90% sure of what I am teaching. Those who are grammar Nazis, I'm sorry, I'm not a linguist. I'm just trying to help these students learn something in this topic. Thank you so much, and see you next time.